Yeah, so when we were trying to find ideas for a project, we really just wanted to solve a problem. So we had a lot of different ideas, but eventually landed upon building a sensor for Parker's three-legged, partially blind dog so that he wouldn't crash into chair legs or walls. First prototype.
Let's go!
Alright, so we first went to Lee's Electronics to get all of our stuff. It's on Fraser. So this is all the stuff we got. We got a breadboard, we got some wires, we got the Arduino. We got the distance sensor, but in the end we didn't, we used that one.
So this is our prototype. We have a battery taped to the breadboard, which is our power source. And then we have the buzzer here on the breadboard with the wires connecting to the Arduino. We have our sensor here with VCC, trig, echo, and ground. So two of those, that's a ground pin and that's electricity. So those go into the corresponding pins on the Arduino. And then trig and echo are assigned to certain digital pins here that we control with the Arduino. Yeah, that's everything. It's Will. I'm gonna explain the Arduino code. So all of these integers are just set up variables. So we say that the trig pin is the third pin on the Arduino. These are all just saying which one it is, and then the max distance here, it's in centimeters. So if I do 400, then it sets the maximum distance to 4 meters for our sensor. This is just set up, so this is more like defining what it is. This actually tells the Arduino that it's in there, but these are the integers, and then this starts communication with the computer. This whole loop is just, it keeps sending the pulse quickly, and that's why dog barking. And this is, if there's no echo received, it turns off the buzzer so that you don't waste energy. This is the distance calculation, so yeah, the speed is around 0.034 centimeters per microsecond, and then we divide by 2 because it has to go forward and then bounce back. All this print stuff is just print to the console so that the Arduino can do something with the information. And then this is the actual calling the beeper. So this is on, and then the beep delay is a variable based on the distance. So it beeps faster when it's closer. First problem we encountered, a broken buzzer.
So our speaker actually wouldn't plug in because the wires were too skinny for the breadboard. So we were trying to solder it to some bigger wires. In the end, we didn't even end up using this speaker because it didn't work. It was broken. So the soldering was completely pointless, but it was fine. It was good to learn.
Sweet, thank you so much.
Just buy a new one.
So we got a new speaker at Lee's. We went back to Lee's, got a new speaker. We were trying to play with it and figure out how we could get it to work.
More problems, the harness size and an unruly dog.
So we got it all hooked up to this harness, but we encountered a couple of difficulties. One was that the harness wouldn't stay on him properly because it was too, like when we got it for him, it was too big, and we were just trying out this harness, but it wasn't working. And two, he didn't like having it on him. He would constantly try to like remove it. We think that in the future we would try to teach him about how to like keep it on and like teach him what the beeps were meaning. We would also have made it smaller so it's more comfortable for him.
I'm saying we got the harness.
I don't think he likes it.
We got the beeper.
Do something!
Alright, so we got it on him. We were trying to get him to move with like treats, like to make him want to try to walk around with it. But he wasn't really liking it. He wasn't really enjoying it. So you can see sees the treats, he's trying to walk, but like you can see that it's not very sturdy and it's like not supporting on him, and it actually makes him harder for him to walk.
Okay.
So he was constantly shaking off the harness and it wasn't working.
We tried to tape the wires to the side so that it wasn't blocking his head.
So we taped on this type.
Yeah, you like put it around the side. See that thing there?
Here
So
we
you
go.
put it around the side so it's not going over the top and like obstructing his head.
So here we are demonstrating the increasing beeping when you get closer and closer to the sensor. Human time.
All right, since it didn't work on my dog, we were like, okay, let's reprogram it for people, and we'll make the sensor like make it beep more the closer you get to the sensor. All right, we got it taped on a hat here, and we're just walking around like just seeing if it worked, and it was working pretty well. Obviously, not the most ergonomic because I have to just hold it
Right.
while we're walking, but yeah, other than that,
Right. No. Stop tension. Go here. Go here.
I'm not gonna be this.
You make me walk down the hallway.
Walk here, bro.
Similar products that we found. So this is similar to what we made. It was made by some Nigerian students, and you can see that they kind of took the shell of a VR headset and kind of modified that into the ultrasonic sensors, and you can see here that they used 3 of them instead, so that kind of just gives a wider range, like more field of view. So instead of our thing, which is just right in front, so we could probably add more sensors like theirs. And here you can see their testing. They put 10 partially blind patients through a series of tasks, and almost 96% of them passed with the product, so it's a good product. And then the next one is a modified cane. We all know how blind people have canes, so this is just a modification that beeps when you actually touch something. And then finally we have the Ausian one. This is kind of a mix of both of those. So it's just a handheld one, so it's not on your face, but you can just, it just beeps in front of you, just holding your hand in front of you when you're walking.
so I called up my grandma. She has vision issues, and I asked her thoughts about the project, and she said that while the longer distance is good, it could be overwhelming if you're turning around and all you're hearing is constant beeps. So make the distance shorter so that people can really understand what it's trying to tell them.
Advantages and disadvantages. An advantage is that the sonar can sense up to 4 meters, so that is quite a large distance, so that gives us a lot of leeway. A disadvantage is just how heavy and large that is. A lot of that is just because we have such a large breadboard, but that is easily fixable, but that does impact the wearability of it. Finally, the fact that the sonar distance is not easily changeable just on the device itself does make it a little bit hard in different changing environments. Areas for improvement. Yeah, so a lot of our improvements are going to revolve around the ability of the sensor to travel 4 meters. So based upon Parker's grandma's feedback, we first thought of a button that we could put onto the breadboard to talk different distances. For example, inside, like she was talking about, so that the sensor isn't always going off and the buzzer's not always going off. And then we also thought that we could have a speed sensor that adapts the distance based on how fast you're going. So for example, if you're walking at a pretty fast pace, only goes off 1 meter before, then you're probably gonna hit the wall by the time that buzzer goes off, and you won't have enough warning. So we can adapt the range of it so that it goes off further or closer depending on your speed. And finally, we would probably make it a more compact design so that it wouldn't have to go in your backpack or something like that. We could just put it on your glasses or your cap, and it would just make it a lot more convenient and comfortable to carry around. thanks for watching, guys. Leave a like, leave a subscribe. Give me some money.